Okay, so I want to look at creating a point class and client. This is covered in the PowerPoint, but I think it's good practice. So we're going to go ahead and start with this example. It may take several videos to complete the work, but I want to, as I'm going through it, I'm going to be talking about some of the reasoning and what are good practices with our classes. So again, the class is like a template for the objects. And in order to create a point object, we have to first write the code for a class. And then when we want to create an instance of the object, we'll create a point. And then to know whether we've done that or not, we need to create what's called a client that interacts with the class. So in some sense, all the code we've written so far have been clients. It's code that is using classes that someone else has written. So for example, when we use a scanner object, the capital scanner is a class that then we create a new scanner in our code. So our code has been a client using the scanner class, capital S scanner class, or this capital S string class, or the random class, or when we did our graphics, the drawing panel, graphics, those were classes. So the class is an abstraction of the object itself, and then when we create an instance of that class, it's called an object. So you have this abstract sort of what is the class, it's a template, and then when you create one, you get an actual object. Okay, so we're gonna go ahead and start. The assignment says create a point class with the following requirements and methods. And in addition, create a point client to test the point class. So the very first thing we're gonna need is, at minimum, we're gonna need to know what the fields are in the class. In this case, it's just two integer fields, X and Y. So that's, in some sense, this thing is a little too small of a project, but it'll give us the idea. And then you need at least a constructor, a way to create a new object. So at least one constructor, we'll do one. And then we need getters. So getters are the methods that allow us to access those fields. They're accessors that allow us to figure out, is it working? Or can I get the values back out? Okay, so we're gonna jump over to Eclipse. We're starting a new chapter, so that's a new Java project, chapter 8. And I would encourage everyone to do this coding and keep it in your code. All of our classes, all of our objects would be similar to this, and we're not going to create the module here. And then within chapter 8, we're going to create a new class. And the difference is right here, our class name is going to be called point, and we are not going to do public static void. We're also not going to do anything here. We're just going to say finish. So this is not going to have a main method ever. The classes do not have a main method. What they need is they need the integer, the fields. So our fields are going to be, remember, an object will contain both data, so those are the fields, and methods, and those are going to be the functions that the object can do. So like, for example, the string that we create the data is whatever is within the quotes, and then the methods that are attached to the string object are all the methods that we have, like to uppercase or to lowercase, all the string methods, the dot that we can use with a string. A character at is one that we've used. Character at 0, we used that for a string method. Okay, we are on a point method. So we have two integer fields, and we want them to both be private fields. So we'll declare them private integer X and private integer Y. Generally, you want your fields themselves to be private. You don't want people coming into your object and affecting those fields without the requirements of the object, without the object doing it itself. So when we want to change X and Y, you have to use a method of the object to change X and Y. You can't just change X and Y. Okay, and then in order to see anything with this point, we're going to need what's called a constructor. So we go public static. There's no void here. We just put the word point in, and we're going to get two integers. So initially, I'm going to say, X initial and integer y initial. And we're going to change this in a second, but I just want to show you something here. So this is our constructor, and it's telling me I have an error already. Only public, protected, and private are permitted. I don't think it's static. Yeah, not static. It's just public point x initial and y initial. So notice the difference here in the class. We have the public class point, and then to do the constructors, we just say public point. Okay, so now what we want is we want to set x equal to the initial value that's coming in, and y equal to y initial. And that is a constructor. And so we could start checking if this is going to work by creating a client class. So I'm going to create a new class, and I'm calling it a client. Anything that uses this object is a client. But just to be clear that we're testing it and we're building it, we're going to actually call this a client, point client. This could be any class that's creating a point, would be a client of the point object. Okay, and here we are going to use public static void main. And within main, so what I didn't do is create my name and headers and all that. Sorry, I forgot. That's okay. Within main, I can now create a point object. Let's call it p equals new point, and you can give it x and y coordinates, say 5, 8. And then we'll run it. And notice there's no errors, it runs. And one reason it's running fine is because the point and the point client are in the same package, so it can see it. So it doesn't have to go outside of the code to try to find a point somewhere else. If you did this without the point class that we just defined, it would define a new point, but it would use the Java AWT to do it. So here it says P is not being used. So one thing we could try to do to test this is we could just print this. Let's try printing P. Unfortunately, what this is going to do, it's going to print it, but it's going to print what type of object it is and where is it. So what that tells us is that we created a point and it's being stored somewhere in the memory. So, I mean, that's good, but it's not what we want because we don't know if it stored the values of 5 and 8. So in order to test that, we need to go back to our point object. And so leave the constructor alone for a minute. So maybe I should tell us here, this is our constructor with 2 parameters. Okay, and now I want to do what are called my getters. Returns the x value. So we're going to go public static. It's going to return an integer. It's going to return the x value. Public static integer get x, no parameters. And all this is going to do is return x. It doesn't like that it's static, sorry. It's because I've been, we've been in main so long we forget. I don't think any of these methods are going to have static on them. Okay, so that's the, that's the getter, get x, and we're going to do another one for y. So public integer get y, and that's just going to return y. And so, rather than saying just returns the x value, returns the y value, I'll just put a comment up here and call this the getters for both x and y. Maybe I'll even not have a space between them because they're such similar functions, right? One is returning x, the other one is returning y. So now I could go back to my point client and I could print, okay, x, let's print a string here, x equals, and then add to that get x, and I need to go not just get x, I need to tell it where are we getting the x from, so it's p dot get x. And I'm just going to copy that same code and paste it below so that I can say y equals p dot get y. And this will check that my get, well, it checks two things. It checks that my constructor worked with the point. It actually stored the values 5 and 8 in x and y, and that x is 5 and y is 8, hopefully. Yep, x equals 5, y equals 8. So well on our way. I'm going to go back to my point, and I'm going to go back to this constructor. And there can also be constructors with different amounts of parameters. So in this case, what would a constructor with no parameters mean? It would be a point that has a default value of 0, 0. And usually the way that you do this is you have another public point that has the same name, but in this case, you could have 1 or 3 or different parameters. In this case, there's no parameters. And we want to call the other point message, or we want to call this. So this will refer to calling this thing with the same name, but now I want to send it parameters. And the parameters I want to send it are 0 and 0. So this would create a default point located at the origin. Now, we don't want to move on. We want to go back to our client, and we want to check that this works. So, and so notice the keyword here, this. This is going to refer back to someone with the same name as me, and it's going to call the point up here, sending it these 2 parameters. And it knows because we have the 2 parameters there. Okay, and this is very common. You always have the one with all the fields coming in as parameters, and then the other constructors call that one with whatever the default parameters are. Okay, so go back to our client, and let's create an origin point. And we would do that by just saying new point and not sending it any parameters. And then let's copy, let's go like this, system output dot print. And now I would want to say quote, let's go origin is, I'm going to add here. So I don't have a toString method yet that's going to allow us to print this in a nice format. So I'm just going to go origin.getX, and then I'll add to that in quotes a comma and a space, and then I'll add to that origin.getY. Myself out of the way. There we go. And we'll run it and see if that's creating the origin. And it is. Origin is 0, 0. So you can see there that we want a method that's going to print the whole string better, or the whole point a little bit better. Maybe I can, I don't like how wide this is, so I can take this print statement. I think I can hit return right there. Didn't work. There we go. Just move that down a little bit. Make sure it's still working. Yeah, maybe tab it in. Even tab it to there and just make it look easier to read. We're going to get rid of it in a few minutes. So it's just to check. I want to go back and I want to do one more thing in my constructor, and then I think I'll close this video and go on to the next video. This is a lot of work if you had to have an initial value for each of the x and the y's. So ideally, we would just have x and y here. The problem is it's going to create, you can't say, oh, x equals x and y equals y. That's not going to work. But what we can do is, again, I can use this keyword to say this dot x, that, notice that is highlighting the x above here. So it's the x, this is referring back to the point because this guy is named point. And so the this is telling it, okay, for the point x variable, which is this guy, you can see it's highlighted. We're going to set it equal to this x, which is the local x here, and you can see it's highlighted there. So this keyword is powerful because it allows us to have the same name for x and y here, and then use the this keyword to access the ones that belong in the point. And then we should go back to the client. Your client becomes your friend in these things. So the client is what's telling us, okay, things are working, and you don't want to try to code like a whole class without checking as you go that everything is working. Okay, I think I'm going to pause this video and move on to the next one. So this is just getting our two constructors and our getters. So we're down to here. And then next we have setters and a translator. So those are like mutators. There's constructors, accessors, and mutators. So the getters are accessors. These are mutators. They're changing things. And then the last three, well, toString is an accessor. It's a way to print out the object. Maybe I'll put that in the next video. And then the other two methods are how does this point interact with other points? So we need a dot equals method and a dot distance from method. So I'll continue that in other subsequent videos.